So this review video is going to be on the binomial distribution, and I know a lot of you had some problems with the binomial distribution, and so I'm hoping that it's going to be a little bit easier and maybe we can talk a little bit more. But I wanted to go over the key points for the binomial to help you kind of understand what it is that I'm looking for in terms of this exam. So first we'll ask the question, what is a binomial distribution? So there are four requirements and sometimes three. In my case, I only use three, but I'm going to give you four of them. The first is that there are only two possibilities of occurrence. We call these the success and failure. So either you have it or you don't. The second is each occurrence is independent from the last occurrence. The third, the probability of each occurrence is the same from trial to trial. And the fourth is that there's a fixed number of trials. And so the best way to understand how these work is to see them kind of in action. Okay? So what a binomial distribution is it's a discrete distribution that takes as the value for the random variable the occurrence as the number of successes. So if I have a certain number of trials or a certain sample size, and I want to know, what's the probability or likelihood that I'm going to get a certain number of successes, what I generate is I generate a binomial distribution. Okay? So this is how this might look. So suppose that we took a sample of four people and asked each person in the sample if they smoke. The probability that a single person will smoke is 0.24. Well, the first thing is do we have that first requirement, right? There are only two possibilities of the occurrence, success and failure. So either the person smokes or they do not. And so consequently, that's your binomial part, okay? Yes or no, smokes or do not smoke. So when we generate the distribution, what we're going to have is this many people in the distribution smoke. Okay, this many people out of a sample of this size smoke. Okay, so that's the first one. The second is independence for the last occurrence. Okay, now, for the most part, I'm just going to let you know that they are in fact independent. In this case, because there are far more, because a sample of four is not 5% of the population of all people, right, smoker or non-smoker, that actually tells me that I can assume independence. Basically, the idea here is that when I pick one out, it's not going to have any impact upon the probability that I pick another person out that might be a smoker. And that is essentially independence. And that's why 3 is basically the same thing. If I pick a person out at random, if that person happens to be a smoker, it's not really going to change the overall number of people who are smokers because there are so many of them and I'm only picking 4. Okay? So, again, sample size is big. Sample size is small compared to the population size. Now, for the purposes of our exam, I'm just going to say, you know what? Each trial is independent. You just have to know that's a requirement. You say each trial is independent. That tells me that I have the second requirement met. And then 4 is there's a fixed number of trials. Well, what that is that there are 4 people selected. In other words, n equals 4. Okay? Now, the reason why something like this is so important is because what we're going to do to generate the distribution is we're going to find, the probability of having X amount out of the 4 be smokers. If we didn't have a fixed number of trials, then there would be no way to actually generate the distribution. It'd be like an infinite number. It doesn't work that way. We can't do the math. Okay? The fixed number of trials, by the way, is basically, do we have a finite sample size? All right? In this case, n equals 4. If we're given a sample size, right, or we're given a number of times that we're going to do the process, then that's our finite, our fixed sample size. Okay? All right, cool. So what we do then is we generate a distribution that looks like this. All right? Now, for the purposes of your exam, you're not going to actually have to generate a distribution like this. But I'm going to do it in order to help you understand what it is that we're doing. So in the case of a sample of size 4, the number of smokers in the sample we could have 0 smokers, 1 smoker, 2 smokers, 3 smokers, or 4 smokers. All right? That's the total number of smokers that we could have in the sample. All right? And what we're going to do is we're going to use StatCrunch in order to tell us what's the probability that if I pick a sample of 4, that 0 will in fact be smokers. So I'm going to go to calculators, binomial. Then I'm going to have n. My n here is going to be 4, and my p is going to be the probability of success, which in this case is 0.24. Okay, compute. All right. Oh, look at that, right? Now, let's say I want to know equals. I'm going to use the equal sign and the probability that x equals 0. So in this case, the value for the random variable, the number of smokers in the sample, is going to be 0. This over here so we can actually do this all at once. And then I go in and I compute, and that's 0.33 actually, 0.33 and 4. Okay. What about the probability that we have 1 smoker out of the 4? So if I pick a random sample of 4 of the 4, what's the probability that 1 will be a smoker? And so in this case, it's 0.421. What about what's the probability that 2 will be a smoker? That's 0.199 or 0.1. Actually, when I round to 3 decimal places, it's going to be 0.200 because the 9 rounds up. About 3. Now it's getting smaller, 0.04. And you should think, if 3 out of the 4 are smokers, that's 75% of the sample's a smoker. But the probability that any one person's a smoker is 0.24. It shouldn't be that high. Okay, so it's getting smaller. That's exactly what we expect. What about 4? That's now very small. That all 4 would be smokers. The probability would be 0.003. Okay, great. So there's my distribution. Now you can go in and actually add them all up as it is a probability distribution. They should all add up to 1, and they do. Okay, and in fact, we can go through and we can find the expected value, which is going to be the mean of this distribution, by doing the process that we use for discrete distributions. But there are easier ways to skin this cat, and so we're going to do that. Okay, we're going to utilize some clever math in order to do that. So let's first figure out what's the important information that we need to glean from this problem for working with the binomial distribution. The first is the n, the sample size, and so n is going to equal 4 in this case. The second part that we're going to need is the probability of success, and so that's going to be 0.24. Okay? Now, utilizing those 2 pieces of information, we can pretty much solve any problem that we have with binomial distributions. So the first question that we have is, what's the mean of this distribution? Well, that mu, my mean here, mu, that's what that is going to equal n times p. Okay, so that's 4 times 0.24. Okay, and I can go in 4 times 0.24. And that equals 0.96. And there we go. There's the probability. That's actually the expected value. So if I picked a person at random, or if I picked a sample of 4 at random, I would expect that 0.96, or about 1, of those people would actually be a smoker. And that kind of makes sense, given that 24% or 0.24 is the probability of any one person being a smoker. So for 4, I just do that multiplication. Now what about the standard deviation? That's now going to equal the square root of n times p times 1 minus p. Now 1 minus p is the probability of failure. So what I'm going to do is I'm just going to insert a little equation here. That's going to equal square root of, and this will be 4 times 0.24 times, and 1 minus 0.24, which is 0.76. And that'll equal, and we just utilize our handy-dandy calculator, 4 times 0.24 times 0.76. 4 times 0.24 times 0.6 equals, okay, and then I'll square root it, and so that's 0.85. And so our standard deviation is 0.854. If we go to 3 decimal places, 0.854, okay? And that's the standard deviation. So you look at it, I've got this distribution, right? The average number of smokers that I expect if I pick 4 will be around 1.96, and it'll have a standard deviation for the distribution of 0.854, okay? Now what we can do is we can utilize StatCrunch or your calculator in order to answer some pretty simple questions about the binomial, all right? Well, what is the probability? Let's look at this first question. What is the probability that a sample of 4 will have at least one person being a smoker? Okay. Now, for this exam, I'm going to require you to utilize your probability notation. So we're going to have the probability that x, and it's at least, so x is going to be greater than or equal to 1. Okay. Now, there are 2 ways you can go about doing this. On the one hand, we could just add up 1, 2, 3, and 4 from here. Okay. But that's actually not the easiest way to go about this. Instead, let's just utilize StatCrunch. Again, I have n equals 4, p equals 0.24, and now that I figured out that at least one smoker is greater than or equal to 1, I just put in greater than or equal to 1, and I compute. And that's 0.666. All right, that's my probability. All right, let's try one more. What is the probability that between 1 and 3 people will be a smoker? Well, that's P. And when I say between 1 and 3, I mean 1, and then I'm going to have less than or equal to x, less than or equal to 3. And so just to make things, very clear, that when I utilize the term less than or equal to, I mean when I use the term between, I mean the less than or equal to. So I'm going to need 1 and 3. So I'll use the between calculator, and it'll be 1 and 3. And that's 0.663. Okay. And that's it. That's all you got to do, right? Once we figured out from our binomial what our n is and what our p is, then it's a matter of basically just being able to read and understand what this discrete distribution is asking us. Now, okay, perfect, cool. What if we change the sample size in this case? Okay, suppose that we increase the number of people in the sample to 50. What is the mean and the standard deviation for this distribution? Well, the mean, okay, which we're going to use mu, by the way, I'm just writing it for the sake of ease, is going to be 50 times 0.24. And the standard deviation is going to equal, actually I'll use sigma for this one, I'll just use the calculator anyways. Sigma equals the square root of 50 times 0.24 times 0.76. Now in this case, we expect that our mean is going to get bigger because that's the average number of people that I'll expect to be smokers out of a sample of 50. I've got more people, so I expect to have a bigger average, right? Okay, so 0.24 times 50, that's 12. And then what about our standard deviation? It's going to equal 3.02, basically, 3.02. And so that's our new standard deviation. And again, we also expect the spread to get bigger because we've just got more. We've got more in our sample. It's a bigger group to choose from. So in this case, if I were to choose it or select an individual at random, okay, or excuse me, a sample of size 50 at random, I would expect 12 of them to be, I would expect 12 of them to be smokers. All right. Now, what about this? For a sample of 50, what is P of X less than or equal to 5? Well, that's really straightforward, isn't it? Because now I just go into StatCrunch. I'm going to change up my N to 50. Okay. And I'm going to change my X to less than or equal to 5. Gives me 0.01, well, wait, 0.011. Okay, so this is 0.011. I don't need to actually use any notation there because it's already written. What is the probability that you'll have at most 10 smokers? Oh, interesting. Well, what does it mean to be at most? Probability that X, and that's going to be less than or equal to 10. Think about what it means to be at most. At most means that we have no more than 10. Okay, so it's probability X less than or equal to 10. I'm going to go in here. And that's 0.318. All right. So for the binomial, it's hard. It's kind of tricky to kind of understand, but once you've seen it done a couple of times, it's a lot easier to work with. Let's just briefly talk about it. So one, you need to know what the requirements are for the binomial distribution. That there are only two possibilities of an occurrence. Each occurrence is independent from the last. The probability of each occurrence is the same from trial to trial. And then there's a fixed number of trials. Okay? And what we want to understand about the binomial is that if we draw a sample of a particular size, what's the probability that we get X number of successes? Okay? X number of successes. And so we saw that distribution that kind of looked like that. We calculate the mean, mu, as being n times p, and the standard deviation for the distribution as n times p times 1 minus p in square root. And so for each distribution, you're going to calculate a different mean and a different standard deviation because they've got different values for n or for p, right? And then finally, to answer these questions, the big thing that you want to remember is, well, what does it mean to be like at least one person, right? That's going to be greater than or equal to, or like at most or between, okay? And then how do you utilize, say, something either like the calculator on StatCrunch, or excuse me, the binomial calculator on StatCrunch, or the calculator that you have, your TI-84, okay? And that completes the binomial distribution section. Pretty quick, right? Just take some practice. I bet you guys could do this and you could do really well. All right, signing off.